Hello everyone, today I am going to walk through the Heroes of Pymoli exercise as outlined in GitHub. Let's take a look at the finished product here before we start our analysis. You can see we're going to create a few data frames. So we're going to be manipulating the data in a few different ways. It looks like we have a gender purchasing analysis, and then we can go into the age demographics, followed by a purchasing analysis split up by age. Then it looks like we're finding some maximum values here for most popular items, spenders, and the top items by average cost. So we'll take a look at the data. We're going to be using JSON here. There's a couple different JSONs that we can use. Either whatever you choose, this code will work for either one. So if your numbers are slightly different, don't fret. The code will work for any data set. And right here, we're just going to beautify the JSON a little bit so we can take a look at what's in there. So we have screen name, age, gender, item ID, item name, and price. So it looks like each little entry here in the JSON is a purchase by a specific user of the Here's a Pymoli game. So now we're going to import our dependencies and get started. Okay, so we imported our dependencies. We're going to use pandas and NumPy, and then we loaded our JSON file of purchase data, and then we set that file to a data frame using read.json, the file name, and then oriented it as records. Now let's take a quick look at the completed solution. First thing we're going to do here is player count. So we're going to calculate the number of unique players that are present in the data set. All right, so we calculated the number of unique players. There are 581 in this particular data set by using loc on the purchase data frame that we created using the JSON. And then we selected the gender, screen name, and age columns because we're really not too interested in the purchase data at this point. Then we dropped the duplicates in that new data frame we created because we're looking for the number of unique players. And then finally, we used count and set it equal to num players. We use count on the player demographics data frame and specify the 0th column. If we didn't specify a column there, we would have gotten 3 values. Here, I'm just going to highlight, we use brackets here because we're not setting an index, so we can't pass a scalar value. So we're going to have to put the brackets there for the data frame to populate correctly. And then the next section, we're going to move along to the purchasing analysis. So now we have the code that we need to create the purchasing analysis summary table data frame. The first thing we did is grab the average item price by using mean on the purchase data frame, specifically the price column from that frame that we created earlier when we first imported the JSON file. Then we used sum to grab the total purchase value. And then for purchase count, we just use count. So we use the same column for those three, but 3 different methods to find the values. And then finally, for item count, we used unique on the item ID column and then grabbed the length of that to find out the number of unique items. Now, there is another way you can do that. If you're curious, you can find the item count by using that same purchase data item ID column, but just using the nUnique method. That will give you the number of unique values in that column. So either way works, but I just wanted to show that quickly as a little trick there. Now, the next thing we did is created our data frame with the values that we calculated. You'll see that some of the values there have brackets because of the scalar and non-scalar rules that we have there for data frames. And then we just did some minor table data munging, table cleaning. We did some formatting to some of our values that are dollar values for the price and the total revenue, and then added a comma for number of purchases. And then we used the look to return that table in the order that we want it. So now we can take a look at the table, and we have just what we wanted. We have number of unique items, average price, number of purchases, and the total revenue for the entire data set. Now we take a look at the solution. It looks like the next area we're going to look at is gender demographics. Okay, so moving ahead, we have our gender demographics calculations right here. We use the player demographics data frame that we created a few steps ago in order to determine the count of each gender category using value counts. So that will give us the number in each of the three categories. And we calculated the percentage by using that gender demographics totals and dividing it by the full number of players in the data set. That will also give us three different values, and then we created the data frame of those values that we created. Again, we do some minor data munging by rounding our decimals to 2, and then formatting by mapping a percentage sign onto the percentage of players column. You can see here we have the male, female, and other categories, and the percentage of players and total count for each. Now we can move on to the purchasing analysis by gender. Moving on to the purchasing analysis by gender, we made extensive use of group bys in this section. Group bys are a good way to group a data frame by column or columns where the value in those columns have a few different categories. So for our purposes, we want to find out the values for each gender category here. So we use group bys and then the sum, mean, and count methods on those group bys to determine the calculations that we needed for the data frame. And then we also renamed each of those calculations. Next, we went to the normalized purchasing total, which was the gender purchase total that we just calculated divided by the gender demographics total count column, which you can see up here in this table that we just calculated in the step prior. Next, we can convert those totals into a data frame. And then for our final step here before we display it, we're going to format some of the columns here. We have a few columns that are in dollars and in currency, so we'll make sure to format those correctly. And then we also format the purchase count with a comma. And then we use loc to get the proper order. And here's our data frame of gender data. You can see that we have purchase count, average purchase price, total purchase value, and normalized totals for each gender category. For the next section here, age demographics, we're going to be using bins and PD cut to slice the data to our liking. It can be a little confusing the first time you see or use PD cut, so make sure you follow along, and thankfully the visualization of Jupyter Notebook does help to visualize some of what we're doing with the bins and PD cut. All right, To start the age demographics section, we're going to establish some bins that we can use with the PD cut. So our first bin here is 0 to 9.9, which you see corresponds to the group name 0 to 9. Our next 9.9 to 14.9, which has a corresponding label, and so on. 14.9 to 19.9, 19.9 to 24.9, 24.9 to 29.9, 29.9 to 34.9, 34.9 to 39.9, and then 39.9 and up. This will allow us to create the correct buckets for the age ranges that we're looking for, and we can calculate the numbers and percentages using those buckets. But the first thing we have to do is use PD cut to slice the data frame using those bins. So we use PD cut on the player demographics age column that we have right here. And use our age bins that we created, and labels will be the group names that we gave to those bins. Now we can move on and continue doing the calculations the way we have been doing them, using value counts. We do that on the player demographics age ranges that we just created, which will give us the value counts for each of those ranges. Then we divide the total that we just created by the number of players to get the percentage of each of those ranges, and then we can create our data frame. Now we'll do some minor data mugging by rounding the numbers and then mapping a percentage to the percentage of players column. And finally, we want to use sort index so that the age brackets are properly sorted. And you can see we have our data frame here with the ages properly sorted on the left-hand side thanks to sort index. And then we have our percentage of players and total count. All right, our next section here is the purchasing analysis by age. So we'll be able to use the bins that we just created once again. So we won't have to do that again, but we will be able to use them a second time in order to get these calculations delineated by the age ranges that we created. Moving on to the purchasing analysis by age, we use a lot of the same script that we use for the purchasing analysis by gender, as you'd expect. We use a lot of group bys and then methods on those group bys. But first, we had to use PD cut and the age bins that we created in the prior step for age demographics to make sure that we had the correct categories. So we ran our calculations, we grouped by the age ranges, and then summed the price within those ranges so we could get the purchase total for each age group, and then renamed that column. We did a similar group by, but then grabbed the mean of the price to get the average purchase price, and then we counted the last calculation to get the amount of purchases. Then we calculated the normalized purchasing using the age demographics total count column that we created in the step prior, and then created our data frame and set it equal to age data. On our final step, we continue to do to make sure our data frames look proper and are in the proper order and have the correct formatting. We did some minor data mugging, and you can see here that we have our age data frame with purchase count for each of the ranges, average purchase price, total purchase value, and normalized totals. Okay, so moving forward, the next section that we'll be covering is the top spenders section. So let's get started with that. Moving on to the top spenders section, we use the purchase data frame that we created when we imported the original JSON file and then grouped by the screen name. So that way we would be able to do calculations for the sum, mean, and the count for each of those screen names and find the top spenders that way. So we put those into a data frame and then continued our last step of formatting and putting our columns into the order that we would like to see them. And then our last step is sorting the values by total purchase value to make sure that we are able to find the top spenders. Now let's take a look at our data frame. And we have a data frame for the top purchase value for each screen name. We have purchase count here, a lot of twos. Just want to take a look at that quickly. I'm sure there's a lot of purchase count twos, but we're actually sorting on total purchase value, so it's not really any concern, but just something to keep in mind. So it looks like we can start moving forward to the next section here, which is the most popular items data frame, which we will create in much the same way, except we'll be grouping by the item name and item ID instead of the screen name. Moving on to most popular items, we extract the item data from the original data frame by selecting item ID, item name, and item price, and then group by the item-specific columns, item ID and item name, to do our customary calculations, namely the total item purchase, average item purchase, and item count, using sum, mean, and count respectively. Then we can do some minor data mugging by creating our data frame and then formatting each of the columns correctly, and then putting them in the order that we are looking for, and then we can sort our values on the purchase count and make sure that ascending is equal to false, because we're looking for the top 5, so we'd like our values to descend. So it looks like we have our most popular items based on purchase count, and we can move forward to the most profitable items section. So this section is very similar to the prior section. In fact, we're using basically the same script, but you'll find that if you do use the same one and just switch out these sort values, you might have an error. So let's go through what we did. So we used a lot of the same script as I had mentioned. You can see the item data there, but then we switched right here at the bottom. We sorted our values before formatting the total purchase value column, and then found the top 5 values. Now let's take a look what might happen if you sort values after formatting. So we'll do that here through some manipulation. I'll show you what the data frame might look like if you had done this in a different order. You can see here the total purchase value isn't correct, and we know that from the prior frame. The total purchase value is much higher. So the issue here is that occasionally pandas might do some strange things where it doesn't read values correctly or thinks things are a string. So just keep that in mind if you're having an issue. But overall, that is Here's a Pymoli. It's a good exercise to manipulate data with a couple different methods, and you've done well. So give yourself a pat on the back.